Alright, this is section 12.1. We're going to be talking about sampling, frequency distributions, and graphs. So we're going to start with the definition. Definition of statistics is the science of collecting and interpreting data. Students should learn the basic idea of the statistics by gathering data, organizing them in charts or graphs, and reading or interpreting from displays. So we're basically going to do all that in this section. Okay, we're going to start with a question. So here we have number 1. The city council of a small town needs to determine if the town's residents will support the building of a new library. The council decides to conduct a survey of a sample of the town's residents. Which one of the following procedures will be most appropriate for obtaining a sample of the town's residents? Okay, so here we have to keep in mind that you can't be biased, basically, right? So if you want to get a good sample of the opinion of the residents, you have to keep that in mind. You can't do the sample towards people that prefer going to the library, or because then the results will be kind of obvious. Okay, so I need you guys to read the following 4 options. It's a multiple choice question here and select which one you think will be the most appropriate procedure for this. Okay, so I'll read them for you. A, it says survey 300 individuals who are randomly selected from a list of all people living in the state in which the town is located. B, survey a random sample of librarians who live in the town. C, survey a sample of persons within each neighborhood of the town. D, survey every 5th person who enters the old library on a given day. Alright, so if we talk about number A, this one says to survey random people from the state. So maybe people that don't even live in this town, right? So that wouldn't make sense, right? Because people are not really going to care. They're like, that's not my town. I don't care. So I don't think this is a good option. Survey random people of librarians. So people that work at a library already. So that might be kind of biased, right? They work at a library, so yeah, why not have a new one? It's another opportunity for them to work in that place, right? C, survey a sample of people within each neighborhood of the town. So here you're selecting all the neighborhoods and you're sampling people on each of the neighborhoods from the town. And then this one, 5th, survey every 5th person that walks into the old library. So I think this one, the most appropriate one that would not be biased and it would take into account a sample of people that live everywhere within the town will be C. And that will be the most appropriate way to conduct this survey. It will not be biased and it will take into account everybody that lives in the town, pretty much. Alright, so it says we're going to move on to construct a frequency distribution table. So in this case, they're asking you to use single values for classes. Number 2, it says a car insurance company conducted a survey to find out how many car accidents people had been involved in. They select a sample of 32 adults between the ages of 30 and 70 and ask each person how many accidents they have been involved in the past 10 years, okay? The following data were obtained. So all these numbers are basically the answers from the 32 adults, and these numbers represent the number of accidents that they had in the last 10 years, okay? So here, this is how we're gonna organize our information. This is gonna be the number of accidents. So notice I'm gonna basically organize this so it looks like the smallest will be 0 accidents, and then 1, 2, 3, 4, and it looks like the biggest number is 5, so I'm going to go up to 5. Okay, now here I'm going to tally the number that I see of each one, and then here I'm going to write the frequency, how many I had, how many adults had 0 accidents, how many had 1, blah blah blah. So first I'm going to go through it. So for example here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here you can go in order, or you can do it like this. So here I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 11. Okay, and then here I have 1, and or you can go like this in order: 3, 2, 1. So I'll let you guys finish this. I want you guys to pause the video and then finish counting how many accidents of each one, and then check your answer with me. Okay, so pause the video. I'm gonna pause it too, and then you guys can check your final answer. Okay, so here I have the total numbers for each of the accidents, the total frequency basically. So I tally each one. I went in order, I tally how many of each one, and then here I basically add up the number that I have for each one. So I have 11 for 0 accidents, 10 for 1 accident, 5 for 2 accidents, 3 for 3 accidents, 2 for 4 accidents, and only 1 adult had 5 accidents in the last 5 years. Okay, now remember that the survey that we have here is for 32 adults, so you want to make sure always the number here, this, add up to 32, which in this case it is 32. Okay, and that is it. That's it. That's how we're gonna do the next problem as well. So hopefully you find this section pretty easy. Let's move on to the next one. Okay, so here we have to construct a group frequency distribution. Here we have the ages of 30 swimmers who participated in the swim meet are the following. So these are the ages right here. All this and all this. Okay, so use the classes. So the classes is basically like the bracket or the breakdown. Okay, so on the previous problem, the classes were like the number of accidents. So we only had a single digit for it. But in this case, we're going to use classes, the range, the number, the ages. So from 20 to 29 is going to be one class, okay? And then we have 30 to 39 and so on all the way to 60 to 69. So we have 1, 2, 3, 4, 5 different classes in this case. Now it says what are the lower class limits? So the lower class limit will be 20, 30, 40, 50, and 60. That's the lower one. Okay, so your lower ones will be 20, 30, 40, 50, and 60. Now the upper one will be the other one. So 29, 39, 49, 59, and 69. Okay, that will be this ones here. That's your upper limit. Okay, what is a class width? So basically, for example, since you have 20 to 29, so what's the width of this? How many numbers are you covering there? So in this case, from here to here, 20 to 29, that is 10 numbers. So the width of the class is 10. Okay, now we're going to do a frequency table again, and I'm going to let you guys work on it. I'll start it. So here is the edges. So these are your classes. And they give you the classes already. So remember the classes are 20 to 29, and then 30 to 39, and then 40 to 49, 50 to 59, and the last one is 60 to 69. Okay, here you're going to tally. Now, what information are we using here? We're using, and here's the frequency. We're using this up here. Remember this information? So this is 20. So I'm going to tally here 1 because 20 is within this bracket, within this class, okay? And then the next one is 38. So I put this one. Then the next one's 38, so I'm going to mark 38 is within this class, okay? So finish the table just like we did it on the previous page, and then check your answer with me. I'm going to pause it so I can finish this table. Alright, so remember we use this numbers to be able to do your tally for each of the classes, so you should look something like this. And then you count how many, so I have 10, 8, 5, 5, and 2. Remember, you always want to double check that this adds up to the number of people or the number of surveys that you're doing. So in this case, we started with 30 swimmers, so it adds up to 30, okay? And that's it. Okay, we're going to move on to the next example. Example number 4 is pretty similar to this one. We're going to construct a frequency distribution for these ages. So it says use 8 classes beginning with a lower class limit of 25. Okay, so I'll tell you what that means right now. It says a medical research team studied the ages of patients who had strokes caused by stress. The ages of 34 patients were who suffered stress strokes were as follows. So here we have 34 patients, and this should be your total over here. So we need to figure out the classes. They don't give you the classes in this case. All we know is that it has to be 8 different classes, and normally you have them in order, and the lower class limit is 25. So this has to be 25 to something. And then the next one, but they don't give you this, okay? So try to figure out what's the lowest and what's the highest. So I'm assuming, let's look at the numbers. Do we have a 25, or what's the highest number that you see? Do we know how big has to be? So I see 61, 62. So if we're going to divide this into 8 classes, I think the appropriate way to do it here will be if we do 25 to 29, and then 30 to 34. So make each class, the width of each class to be 5, okay? And then 35, 39, 40 to 45. And we're going to keep going till we have 8 classes. And then we're going to do the tally. Oops, this should be 44. And this is 45. So we're going to keep doing this. 59, 60, and 65. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 classes. There you go. Okay, so now you're going to do the fun part. You're going to do the tally and make the little tally and then count the frequency. So write down the total numbers. I'll let you guys work on that. So pause the video so I can do that myself as well. Okay, and then check your answer. Alright, so after doing the tally, you should end up with something like this. Okay, these problems are kind of easy, right? They're just time consuming to go through all the numbers and make sure you don't forget any. So if you're organized, you shouldn't be a problem. So we should end up with 34. That's your total. And this is your beautiful table, okay? Now in class, we're going to do the rest, which is the different types of graphs for the next pages. So thank you for watching this video, and I hope you find this section pretty easy. Okay, thanks.